Hello everyone, we are Group 3 and my name is Marcus Berkshire. Our partners' names are Jake Babcock and Arnav Brahma. Arnav will be submitting a separate presentation. Advanced manufacturing technology is constantly changing and will continue to change into the future. Some examples of advanced manufacturing are additive manufacturing for biomedical applications, advances in 3D printed structures and materials, advanced robotics for manufacturing, and implications of the Internet of Things, virtual reality, and big data for manufacturing. Today we will give more insight in 3D printed structures and materials.
In today's presentation, we'll provide a state-of-the-art review of 3D printing, and then we'll move into the future of 3D printing within 5 to 10 years and how it will have an impact on the industry. 3D printing, or additive manufacturing, is a process of making three-dimensional solid objects from digital file. In the additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced horizontal cross-section of the eventual object. A long time ago, 3D printing was only thought of as being theoretical. However, 3D printing is now reality. Within recent years, 3D printers have become much cheaper to produce and buy, and many models are now available for purchase, as well as many designs for products. It becomes clear as to why 3D printing is now a reality when comparing it to traditional manufacturing, when looking at their materials and their structures, and when looking at the most commonly used 3D printers.
3D printing versus traditional manufacturing. One of the biggest advantages of 3D printing that 3D printing has over traditional manufacturing is that 3D printing generally does not require any further processes or special tooling to make a part. In making a prototype, this will reduce the completion time, cost, and effort that would normally be spent on getting an assembly process set up if a traditional process was used. Another key advantage of using 3D printing over many traditional processes is the huge difference in waste prevention. 3D printers are incredibly resource efficient. Only material that is passed through the extruder of the printer is consumed. However, traditional processes such as injection molds require extra materials to fill the mold. On the other hand, 3D printing does not beat out traditional manufacturing in every category. When dealing with large-scale production and when you've moved past the prototyping phase, the additive manufacturing process is less efficient than traditional ways of making parts. When working in large scale, assembling the objects would take extremely long compared to assembling them in a traditional production line. Overall, 3D printing processes will likely not completely replace traditional manufacturing. However, this process does display an incredible option for one-off production runs and small custom work pieces. Within 3D printing, there are many materials that can be used to fabricate a chosen part. With the use of different 3D printers, different types of materials can be used, such as polymers, metals, and also ceramics. The most commonly used materials are nylon or polymod, which is commonly used in its powder form and will undergo the sintering process or be in a filament form with the FDM process. This plastic is a strong, durable, and flexible material. PLA is a biodegradable plastic material that can be used in resin format for DLP processes or filament form in FDM processes. This material comes in a variety of colors and can also be transparent, which has proven to be useful for some applications of 3D printing. Gold and silver are two strong metals which allow the printed object to be made from wax and then casted in a later stage. Lastly, ceramics used in 3D printing are very rigid, delicate, and are typically white. Within the printing process, the ceramic is first printed and then the surface is glazed. Structures can make our lives much easier by creating prostheses and other objects used in projects aimed towards preserving the environment. Common and useful objects that can be 3D printed include food. 3D printed technology can now achieve the production of food. Food is printed by using different raw materials, and many food can either be made into liquid or puree. Another structure is parts and pieces. These prototypes are very important in the design process and allow necessary design flaws to be seen and corrected. Examples of some 3D printed prototypes include gears, engines, simple electronic components, etc. Next, 3D printed organs and human tissues can be used in the field of medicine, especially when used to create personalized biomedical implants through 3D bioprinting. Lastly, environment. Coral that is in danger of disappearing can now be preserved and the ecosystem can be revitalized so that it can be as it was before. These new reefs have more complex structures and last much longer than natural reefs. Therefore, the ecosystem will be maintained and regenerated without any recurring problems over time. There are many different methods of 3D printing. The method used most often is a process called fused deposition modeling. FDM can often be used in homes and can make 3D printing a fun and easy hobby. The material used in FDM is a thermoplastic film, which is first heated to its melting point and then extruded layer by layer until a 3D printed object is created. Also, a support material is used which supports the object as it is being printed.
3D printing in the next decade is estimated to grow dramatically. Skeptics in the past have argued that 3D printing won't be able to compete with the efficiency of mass production, but throughout its progression in recent years and due to the estimated progression to come with its technology, the claim is becoming less and less factual. Its increasing ability to print a larger variety of materials, as well as print more parts in a smaller time period, suggests that it will be very useful to many industries, such as the automotive and aerospace industry, as well as the biomedical industry. For metals, in the past there have been complications with 3D printing metal components due to the forming of pockets of gas in the laminated layering of materials. This is considered a large issue because gas pockets within structures compromise its ability to withstand fractures and fatigue. Coming up with a method of 3D printing for alloy metals is one of the main areas of research for its future development. Another one of the main issues with printing metals is that it's very expensive. The high cost of printing is due to the expensive high-quality metal powders which must be used for the process, as well as the expensive printers themselves, as no traditional 3D printer is capable of printing metal due to the high heat required to melt the metal. The improvements being made today are heading in the direction of making 3D printing of metals much more time and cost efficient. For composites, the growth of composite 3D printing is still largely threatened by the metal industry, and it requires significant improvement before it will be viable for manufacturing. The main difficulty faced with 3D printing composites is that the powder material used for printing results in a limited fiber length and therefore compromises the properties for the structures for which it is used to make. Currently, research is being done to employ a method of 3D printing composite parts in order to achieve extended fiber lengths and therefore not hinder the structural properties of composite parts made through 3D printing. It's likely that within the next decade, it will be possible to 3D print more components with larger fiber lengths and therefore a larger variety of composite 3D printed parts. For metals and composites, advances in 3D printing materials are expected to have a huge impact on the aerospace, automotive, and biomedical industries due to the ability to make very complicated shapes with minimal waste of materials as opposed to traditional manufacturing. Enabling manufacturers to produce metal and composite parts through the process of 3D printing would enable them to make changes to their products simply by modifying the computer model being used to produce the part. This would reduce in huge cost savings due to the fact that engineers would no longer need to modify an entire production process to modify a part being produced. In addition, 3D printing of composite and metal will result in the ability to make strong, intricate parts much lighter than ever before. For automotive and aerospace industries, this will mean that vehicles will be much lighter and will therefore require less fuel. In conclusion, 3D printing is a constantly changing process. As new printing models and materials become available, 3D printing will grow further into a common and efficient part-making device.